Rujwa,
Hello, sir.
can you hear me?
Yes, please.
Okay, let's just see if anybody. Give them a few more minutes, okay?
Pardon, sir.
We'll wait a few more minutes to see if anyone else comes, okay?
Okay, thank you, sir.
Okay. One thing up there, right?
I know.
Okay, take it.
Oh.
By the morning. I'm gonna take you next week, you know that.
Okay.
Yeah, we're gonna change it.
It's going to be so nice.
Yeah, next week. Yeah. It'll be interesting.
Yeah.
We're coming from the big dance.
Yes, I have.
Sam, you were sick?
Hello.
Hello there. All right. We have a Rujwa online. And we have Alex and Formulae there. Okay. Go on over. Okay. Oh, let's see. I'd say, yeah, it's going to be quite an interesting morning tomorrow, I think.
There's really a serious production outside. I didn't realize it was this serious.
Yeah, I didn't realize it was serious either.
Yeah, the whole.
Yeah. The whole show is going to be done from here. Yeah, I do. Okay, all right. Let's have, who else we got here? So just, okay, Rujwa,
Sir.
we're going to go now. Okay, so let's share. What am I doing? I'm going on to, can you see this blank screen, Rujwa?
Yes, sir, I can.
What does it say now?
H. I. Hi.
Yeah, that's right. Okay. All right. So let us do this. Let us do that. What time boarding? What time is dinner? Oh, Sam. So what do you do? Good. Take one. I'll take one. All right, guys. That's it.
Really chilly.
Okay. So, no, we'll close the door now. Okay. Grade 11. Okay. You're going to have to know which is relevant for this. Right. Okay, first of all, see, you're on a Cartesian plane, remember? We're only going to do, we're not going to do triangle trig in this fortune exams. Okay, and you have, remember your angles start from there. Go anti-clockwise, right? So, Rujwa, can you hear me?
Being clear, sir.
Okay, like 270, 360. Okay. Remember, we can also go in the opposite. So that's if I'm going in that direction. Going in the opposite direction. Okay. So if I travel in that direction, then traveling that direction means the angle is going to be negative, right? So that'll be negative 90, negative 180, negative 270, negative 260.
Will the negative angle influence whether the cos sign will be negative or it's just negative in
So really what you're going to have to figure out is which quadrant you're going to be in, and that's going to be really how you get there, whether it's a negative or positive direction. So remember that if I travel through, let's say, 100 degrees, and we end up at that point, it'll be exactly the same as if I traveled in this direction. So that would be negative 2. So traveling through 100 degrees in a positive direction, that traveling through 100 degrees is the same thing as traveling through negative 280, negative 260. They're going to add up to 360. So that negative 260. We think because I add up to 360. So traveling through 100 is the same thing as traveling through negative 260, just in an opposite direction. With me? Okay. You with me, Rajwa? So it's just about where you end up. Doesn't really matter how you get there. Okay. All right. So now, if you're in the Cartesian plane, okay, and I measure an angle of theta, that's the x-axis, that's the y-axis, is 0 degrees, and then the distance I've traveled across is the x-coordinate, distance I've traveled up is the y-coordinate, and the distance from the center to the point is your radius. The trig looks at those ratios. Okay. So, and in the definitions, you've got to know this. Okay, that sine on the Cartesian plane is the ratio of the y coordinates of the radius. So it's one thing, an understanding thing. Okay, so on your calculator, if we went, and it's going to do one example like this, and we measured an angle 30 degrees. Okay. On your calculator, what do you get if you go sine of 30? You get a half, right? Okay. Now, sine is the ratio of the y coordinate of the radius. Okay. So now it's saying to you that the ratio of y over r for an angle of 30 degrees will always be equal to a half. It doesn't mean, it could be that we're at this point over here, let's say, where the y coordinate, doesn't matter what the x coordinate is 1, and the radius is equal to 2. You with me? We could be working at that point. But we could also be like over here, I'm going to do it to scale. But let's say then if the y coordinate was 10, radius, the ratio must still be 1 over 2, right? Of y over r. So that'll be 1 over 2. So in that case, the radius would have to be. But along the 30-degree line, it stays fixed. You with me? So if we had another point over here, and let's say this was equal to, I don't know, 200, the y coordinate. Well, that was 1. I times about 200. The original radius was 2. So if I times that by 200, I'm going to get. Okay, so it could be a half, but it could also be 200 over 400, which simplifies to a half. You with me? Okay, or it could be 10 over 20. So it's just about the fact that all the sine 30 degrees means for an angle of 30 degrees, the ratio of y over r stays fixed. Okay. All right. So sine theta is equal to y over r. Okay. Those are our definitions. Cos theta is going to be equal to what? X over r. And tan theta is equal to? And our stupid poem was? Shade your rear. Why? Because X-rays. Okay, so you got to know those definitions. Okay. Right. Then, Ridra, you with us?
Yes, sir.
But maybe you're going for a snack. Oh. Now times I got to flash up at 4 o'clock and say, can I have a finish? And we run out of break. Well, isn't there a kitchen here, which is probably full of bread?
Yeah.
So, it's like they don't want to make money. They're like determined not to make money. Okay, right. So now, okay. So those are your definitions. Now remember, on the Cartesian plane, again, if we're not the diagram that's important. Okay. Remember, we talk about this being quadrant 1. I don't know why we use Roman numerals, but we do 2, 3, and 4. So in quadrant 1, well, if you took a point in quadrant 1, the x coordinate would be positive, the y coordinate would be positive, and the radius would be positive, right? So all of these ratios are in positive numbers, right? That's why in quadrant 1, all of your trig functions are positive. Okay. Where, okay, what's negative in quadrant 2? The x, if you took a point in quadrant 2, the x coordinate would be negative, right? Which is why cos is negative, okay, and tan is negative, but sine, the y coordinate, the radius are positive, with me, which is why sine is positive in that quadrant. Okay. In this quadrant, well, if you took a point there, x and y are both negative, right? Okay. So tan is going to be negative over a negative. Everything else will be negative and positive. So the only thing that's going to be positive is tan. Okay. And in this quadrant, well, the x coordinate's positive. So that'll be positive over positive, but that'll be negative and that'll be negative. So in this quadrant, so remember this diagram, this all students talk crap diagram, okay, tells us what? Where the trig functions are positive. Okay. Right. Then for reduction, you always treat, okay. So when you have things like 180 minus theta, and then we do this reduction formula, in your head, always treat, doesn't have to be, just a way of remembering it. Always treat theta as an acute angle. Okay, so for anything where you got a reduction, okay, what does that mean? It means when I talk about 180 minus theta, it means I always think about how have I traveled. Okay, so for reduction formula, okay, there's 270, there's 360. If I talk about 180 minus, what does that mean? It means I've gone round to 180, and then I've gone back a little bit, right? So 180 minus theta always behaves like it's in quadrant 2. You with me? Whereas 180 plus theta means I've gone around to 180, and then I've got a little bit more, right? Okay, so 180 plus theta behaves like it's in this quadrant where tan is positive. You with me? 180 minus was I gone around, sorry, and gone back a bit. So 180 minus ends up there. And 360 minus, okay, you've gone all the way around to 360, right? There's 360 degree. And then you've gone back a little bit. So that's 360 minus theta. You with me? And I end up in this quadrant. And in this quadrant, you have cos is positive. Yeah. Right. You still with me? Yeah. The reduction formula, okay, I think isn't bad. Okay. Just take a bit of getting used to. If I do some simple reduction formulas. You know what you are?
Yes, sir.
Is anybody else online?
No.
Check at these, actually. All big promises. Right. Okay. But when they're sitting there up as far, they're like, okay. All right. So the kind of question you do is that they could say write as a function of theta. Okay. So if it's 180 plus or minus, so I'm going to look at these three, or 360 plus or minus, and negative angles. Okay. Just going to look at these ones to start off. So if I said to you, right as a function of theta, and I said number one, so at the moment we say that this is a function of 180 plus theta. Okay. So I want to end up with just something theta, right? So what I do, I say, right, where's 180 plus? Okay, 180 plus is over here, right? Okay, in that quadrant, what happens to sign? It becomes negative. So it's just going to be okay. If I gave you this, try to do that one, and then try to
Hello, sir.
mm-hmm.
Oh, you're still here. Sorry.
Yeah. Rudra, everything okay
Yeah.
there?
Yes, please.
Okay, great. Okay. All right. So, Alex, if I had 360 minus, which quadrant am I in? Okay, quadrant 4. I've gone to around 360. So what happens to cos? It stays positive. Okay. Was he 180 minus? Where am I?
In quadrant.
Good. In quadrant 2. And what happens to tan there?
It's negative.
Good. Okay. Right. Now, even if I go and I gave you this, I'm going to do these ones. Remember, a negative angle, always treat the angle as if it's acute, even if it's not. Negative angle always behaves like it's in quadrant 4, right? Okay. And because if I mean, the explanation is this. If I just took, for example, 30 degrees, you don't have to write this down, and negative 30 degrees. Okay. Degrees where the x coordinate would be the same. So if this coordinate was √3, that coordinate would be √3. Okay, the y coordinate would be 1, the y coordinate here, that would be -1. So cos of 30 would be root, and the radius would be 2 in both cases. So cos of 30 would be √3/2, and cos of -30 would be, okay, also √3/2. That's why cos of a positive angle and cos of a negative angle are the same thing, because their x values have the same sign, okay? Whereas if I took sine of 30, that would be y over r, which would be a half, but sine of -30 would be negative a half. And tan of 30 would be 1 over √3 y over x, but this would be, so the only one that's the same is cos, right? So the way you remember it is at a negative angle, okay, in quadrant 4, okay, what happens in quadrant 4? Cos is positive. Okay, so if I said you write as a function of theta, and I gave you sine of negative theta, it would be the opposite sign to sine of theta. Okay? But cos of a negative angle has the same ratio of x over r as cos of that. And tan of negative theta okay. So the only one that stays positive when I write it as a function of theta as opposed to a function of negative theta is cos. Well, you remember it, remember cos in quadrant 4, treat a negative angle like it's over there. Okay. So with me, guys? Okay. Right. Now,
Yes, sir.
even if you have weird ones, where it's the wrong order, like say I gave you this. sine theta minus 180. So it's not just bouncing off the axis 180 minus. It's a bit weird, right? Even then, so I think this current takes out a negative. I don't take out a negative. Okay, what I do is this. I'll say, okay, where am I? What is, if I travel through theta, it means I've gone a little bit there. Okay, then I've got to travel minus 180, which means in the opposite direction. That'll be minus 180, right? So where am I? I always say to yourself, where do I end up? I end up in this quadrant, right? In that quadrant, what happens to sine? Well, the only thing that's positive is tan, right? And so it's just going to be. So you can go take out a negative and then use a negative angle definition and blah, 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 and do it in 5 lines. But you can just say, where the hell am I? Okay? And what happens in that quadrant? But just treat theta like an acute angle, right? So positive theta means I've gone through. That negative theta means I've gone. Always treat negative theta like an acute angle. Okay, so if I gave you this, tan of negative theta minus 180. Let's try to figure out where you are. Which quadrant am I going to end up in if I travel like that? Okay, right. Negative theta minus 180 means I've gone how? I've gone through negative theta and then another negative 180. So I'm in quadrant 2. And what happens to tan in that quadrant? Negative, right? I don't know. I find it easier than taking out a negative. And last one, if I gave you this, that's fine. Okay, right. So that's when all of these ones I've been talking about, we've been bouncing off 180, right? Or 360. I say we're bouncing off the x-axis. So if a reduction formula question involves 180 and 360, all we have to figure out is where are we? Is it going to be positive or negative? Okay. However, okay, we get, that's what we're getting to. Okay, your COCO rule, whatever it is. Okay, so reductions for 90 degrees plus minus theta. Okay. And really, again, you don't have to write what I'm about to write down now. If you want to, you can. So if I took an angle of 30 degrees, I'm just going to use special angles. Okay. Right. And I just drew in that right angle. At this point would be root 3, 1, that'll be 2. Okay. So if I said to you, okay, let's just do these 3 ratios quickly, just practice. Go write down for me, if that's x, that's y, and r. Write down what cos 30, sine 30, and tan 30 are. And I don't worry about tan, just cos and sine. Hear it well?
Yes, sir.
Where's home?
Home is in Athol.
Tell Athol I said hi.
Okay, will do. Hi.
Thanks, man. Okay. What's our definitions? Say your rear y is x raised to what? Yeah. So cos of 30 is going to be what? The x coordinate is root 3, the radius is, and sine of 30 is going to be, promise you, if you're checking your calculator, you'll see those odds. Okay. Now, let's think about this. If I go and keep a radius of 2, that's important. So now, that's 90 degrees. I keep a radius of 2. and I measure an angle back here of 30 degrees. Now keep a radius of 2. Okay, this is just an explanation. That's okay, but I don't know. And now I go back 30 degrees. So what you've got then, you've got a radius of 2, 30 degrees. Okay, and we keep a radius of 2 over here, and we do that. These triangles will be similar triangles. Okay, so that's 2. What was this distance here? It was the distance across. It was √3, and that was 1, right? What will this distance up here now be? Those triangles are actually not similar, they're congruent, sorry. They're congruent, side angle. So this distance will be √3, and this distance will be, do you see that? Okay. In other words, this point will be the point. Okay. What's the x coordinate going to be here? You've gone 1 across, right? And the y coordinate will be √3. So what's the size in trig? Where do we measure angles from? The positive x-axis from here, right? So that angle is 30 degrees. But what's this angle over here? Well, it's 90 and you've gone back 30, right? So this angle, do you agree with me, is 60, right? Okay, so here is your ratios for 60 degrees. You've traveled through 60 degrees. Your x coordinate is 1 and your y coordinate is √3. So if I said to you, go write down now for me what cos 60 is and what sine 60 is. Hello?
Hello, sir. Oh.
Hi, Rutva. Okay. Hello, guys.
We finished up with 6. Okay.
Yeah, thanks. Okay, right. So cos of 60. So what's cos of 60 going to be, guys? It's x over r, right? If you've traveled through 60 degrees, what's your x coordinate? It's 1, right? Your radius has stayed fixed at 2. And what's sine of 60 going to be? √3 over 2. Because it's your y coordinates of your radius, right? So what's the same with 60 and 30? The sine of 60 is the same thing as cos 30, right? And cos 60 is the same thing as sine 30. And the reason why is because if you've got an angle and 90 minus the angle, what will happen is your x and y's will swap around. Okay, because how much you've gone up will, in that case, for 90 minus will become how much you've gone across. Okay, how much you've gone across will become how much you've gone up. Don't remember that explanation, it's not the end of the world. But what we say is that sine, what's the word for adds up to 90? What's the things, two angles add up to 90 degrees?
Oh,
Complementary. Okay. So this, when you talk about your cocoa things, it's your complementary functions. Okay, which is where the names come from. Okay, so what we're going to say is that sine of 90 minus an angle, like sine of 90 minus theta, is the same thing as cos of an angle, and cos of 90 minus theta is the same thing as sine of an angle. Okay, in your head though, guys, you've got to have it clear. You don't have to show any working. Okay, so what's going to be the same thing as cos of 20 will be equal to, go right down, it's going to be sine of what? Sine of 10 would be equal to cos of what? 10, sorry, let's do one more. Cos of 2 degrees would be the same thing as sine of what? Don't have to show any working.
so cos of 20 will be equal to sine of 70.
Good.
Sine 10 is equal to cos 80.
Good.
Cos 2 is equal to sine 80.
Good. Okay, so whenever you see that, you can interchange those things. Okay. Just like cos 60 is the same thing as sin 30. Sin 60 is the same thing as cos 30. And this, guys, is actually where the name of the trig function comes from. The original trig function is sine. Okay. The actual name for cos is, what does that mean? Why is it called cosine? Because it's a complementary function of sine. Somebody there?
Oh,
It was really like, they've got some pieces. Okay, not literally there for like 3 hours. What it takes.
You guys are going to be cold tomorrow morning. They're starting to broadcast at 6. But they put themselves some heaters because this radio is cold at 6 in the morning. Okay. All right. So you with me on that? Okay. So now, if I have reductions for 90 plus, how are you doing there, Ridwell?
I'm doing great, thanks. And you, sir?
Good. There's much activity outside my classroom.
Oh,
Setting
really?
up for the radio show tomorrow.
That's
Well,
so
it's actually a
interesting.
TV show, really.
Oh, wow.
Yeah, it's broadcast live on the internet. But on the radio, people don't have things to do. Right. Okay. So now, okay. If I have you heard it nearly before? 94%.
Yeah.
Quite funny, actually. Okay. Right. Now, so if I said you express as a function of theta. Okay. I'm waiting. Okay. Right. So we've done these two. Okay. But say I gave you, okay, sine 90 plus theta. The 90 is like the dangerous guy. Okay. So what I do is this. Okay. Where is 90 plus? What does that mean? I've gone through 90, and then I've gone a little bit more. But what quadrant am I in? So whether it's positive or negative, okay, is determined by the original name. And what happens to the original name? So you say, okay, I've gone 90 plus theta, I'm in quadrant 2. What happens to sine in that quadrant? So first do the sine. But then whenever there's a 90, sine's going to change to cos. Okay, so go try this one. Chaos. Okay. 90 plus. Which quadrant we're in? We're in this quadrant. What happens to cos in that quadrant? And it changes names too. So just remember positive or negative according to the original name. And if I gave you some weird ones, so say I gave you what did I just say? So where do I end up? Okay. So I think where are you going to end up if you travel through theta minus 90? Where are you going to end up?
Wouldn't it be sine theta?
Okay, so Richard, where are we going to end up? Which quadrant? 1, 2, 3, or 4?
We are going to end up in 1.
Let's think about it. Okay, so how have you traveled? You've traveled through theta, right?
Mm-hmm.
Which means I've gone there, right?
Mm-hmm.
Okay, then I've gone back
Oh,
90.
I see.
So I've gone back 90.
Mm-hmm.
It's like a right angle, right? So I
Yes.
end up in quadrant 4, right?
Oh, I see what you're talking
You
about.
with me? So what happens to cos in quadrant 4?
It becomes negative.
Careful. All students talk crap. Cos is positive, right? Positive or negative according to the original name.
Oh, I see, yeah.
But then there's an evil 90, so it's going to change to fine. Okay.
Can you please explain that? Whenever I see a 90 and
Whenever you see a 90 in a reduction formula,
Mhm.
you must change cos to sine and sine to cos. 180 and 360 doesn't change.
Oh, okay.
So try this one. If I
Yes, sir.
gave you guys sine of minus theta minus 90,
Mhm.
we'll have a little 2-minute break now. Going like the bone. Minus theta minus something. Figure out where you're going to end up. What have I done? How have I traveled? I've traveled the original
Mhm.
through a negative angle, negative acute angle, right?
Mhm.
Then I've got 90 more in the same direction.
Mhm.
I'm in this quadrant here. Are you happy with that?
Yes, please, sir.
What happens to sine in that quadrant?
Sine is still negative.
Good. But there's an evil 90, so it's going to change to
Cos. Negative.
Okay. Last one, and then I'm just going to have a 2-minute break. If I gave you cos of negative theta, okay, that's done. So let's just leave it at that. Okay. All right. You want a 2-minute break, or should we just go? Okay. Push on. Okay, let's push on. Okay. Right. You sort of with me, Rajma?
Yes, sir.
Okay, so now this revision exercise. Okay. So let's have a look at their reduction questions. So this comes from exercise 4.1 on page 130. Okay, and the question says simplify. Okay. So if we gave you this, number 1, so this is question C1. Okay. If you had cos 180 minus theta times cos 90 minus theta of sine 90 plus theta and sine. So this, we don't normally ask just one thing, we normally ask it like this. Okay, so the first thing I would do, guys, in questions like this, to stop careless mistakes, is put big brackets around each of the big functions. Okay. When you write at your next step, then keep those brackets there. Okay, so try to do those 4 reductions. When do we have it? What's the number we look out for a name change? Which one? What's the evil number?
90.
90. Okay, if it's not 90, there's no name change.
Yes, sir.
I'm going to help you with that 720 now. Okay, when we get to it. All right. So, but let's do these ones. Right, 180 minus theta. Okay, 180 minus, I'm over here, right? What happens to cos Z? It becomes negative. So is there going to be a name change? No, because there's no 90. Okay. 90 minus theta, where are we? We're in quadrant 1. All trig functions are positive, but cos is going to change to 5. Okay. 90 plus, I'm in this quadrant. What happens to sine in that quadrant? It's positive, right? Original name. But then there's a 90, so it changes to cos. Over here, well, if I've traveled minus theta, I'm over there. And another 180, I'm over here, right? In that quadrant, what happens to sine? Okay, so if I've got, what's this overall sign going to be? Negative at the top and positive at the bottom, right? So it's going to be negative overall. Coses are going to cancel. The signs are going to cancel. When you cancel, don't cancel so much we can't see what's underneath. Okay, so it just end up going to be negative.
Is it fine if you don't indicate?
Yeah. Probably even better. Okay, try the next one. Right. Now let's just, before we start the whole thing, for angles bigger than 360, I think I'm going to change to the way Mr. Karam teaches. Okay. So for angles bigger than 360. Okay. All she does is what does she do again? She keeps minusing 360. Okay. So keep minusing 360, because if you minus 360 in trig terms, you're back at the same point. Okay, you with me? So 720, okay, is going to be equal to, so 720 minus 360 is 360. Okay, so 720 is the same thing as, I've traveled through 720 on the 360 is once, 720 is twice. You end up at the same point. So in trig terms, 720 is equivalent to 360. So if you want, you can immediately underneath there, right? 360.
So you don't need to put a 2.
No. Just 720 is the same thing as 360. Yeah.
What if it isn't?
So we'll look at those. They're going to come up. Okay. So tan of 720 plus theta. Okay, so just keep minusing 360 until you get a number smaller than 360, and that'll be the equivalent ratio. So 720 plus theta is the same thing as 360 plus theta. Right, let's put our brackets around here. There's one thing I don't know if it's going to come up, but remember, can you remember this? What is sine theta over cos theta equivalent to? Tan theta. Okay, right. Okay. So, how do those reductions? We tried them. Okay. 180 plus theta. Which quadrant we in? We're in that quadrant. What happened to cos then? Good. Does it change names? Right. Urudra, a negative angle behaves like it's in quadrant.
In quadrant 4.
So what happens to tan in that quadrant?
Tan is going to be negative.
Good. Okay. 360 minus is also in quadrant 4, right? So what happens to sine? It becomes negative. Now where's 360 plus, guys? It means you've gone around to 360 and a little bit more, right? Okay. So they're all positive in that quadrant. So that's just going to be tan theta. Okay. So how many negative signs do I have? They're all timed. If they're all timed together, I just count the number of negatives. If it's odd, it's going to be negative. If it's even, it's going to be positive. How many negatives do we have? 3. So it's going to be negative overall. Tans will cancel. So I'm left with negative cos theta over sine theta. Now, guys, if sine theta over cos theta is equal to tan, then cos theta over sine theta is equal to 1 over tan. If you flip both things around, okay, so this is equal to negative 1 over 10. It's vaguely coming back to you guys. All right. Okay. Rujo, have you got this down?
Yes, sir, I do.
Okay. All right. So now I'll tell you one last one. Okay. To check something. So just remember, whenever you get a square in this section, so let's say I gave you squares in induction. Okay. I gave you sine of 180 plus theta, sine squared, sorry, 180 plus theta. So the squared is there above the end. Sorry, so I'm not rewrite it. But sine squared 180 plus theta. What does that really mean? It means sine of 180 plus theta. So I immediately, if I was writing a textbook, cross out this 2 over here, put it in a bracket and write it over there. Means the whole thing squared. Okay. So even though 180 plus, what happens to sine there? Negative, right? But as soon as you see a square, because of the squaring effect, if you square a negative number, what happens? It becomes. So if I see a square, I know that the final answer is definitely going to be positive for that. Okay. So the important thing to remember is remove that square and place it over there. Right, we need it there, guys. Okay. So I'm going to do this question, and I think your brains are cooked. Okay. Next lesson. Okay. Right. Otherwise, it's an information overload. Are we happy up to there, everyone? Okay. So this, one other thing, just remember, okay, which is going to be relevant for identity, okay, is remember sine squared theta plus cos squared of the same angle is equal to
1.
Remember that. Okay, sine squared of an angle, cos squared of the same angle. So sine squared 22 plus cos squared 22 would be equal to 1. Sine 22 plus cos 22 would not be equal to 1. It's got to be squared, right? And likewise, sine squared, if the angles are different, I don't know what they'd be equal to, but they're not going to be equal to 1. Okay. What's useful in identities, not so much now, is that then we have cos squared theta, if we manipulate that equation, would be equal to what? And sine squared theta would be equal to what using? Makes sense.
Third one,
That'll be 1 because it's squared. That wouldn't be 1 because they're not squared. If you can cut 23, 24. The angles are different thing. Okay. So go write down what cos squared is equal to in terms of sine and what sine squared is equal to, okay, in terms of cos. Okay. Very nice. Good check. Okay, so cos squared is equal to what, guys? 1 minus sine squared, do you agree? And sine squared is 1 minus cos squared. Okay, So the next kind of questions is this type of question, where they say to you, if given, the last question, tan 22 degrees is equal to t, okay? Write the following in terms of t. Given tan 22, this is question from exercise 4.1, question D. When tan 22 is the t, write the following in terms of t.
I love this question so much.
I like this one.
It's like a nice easy.
Okay. So just pick up a few tricks, that's all. Okay. So here we're going to be using reduction formula mainly. Okay. So what's really the question saying? The question is really saying, get everything to tan 22. That's what the question's really saying. Okay. So the first question is tan 202. The second question is tan 338. Okay, try those two, see what you remember. So you've got to force 22 into the sum. Okay, look for 180 and 360 always first. And your first step is you're just rewriting the number. You're not applying any reduction yet. So your first step is you're rewriting that number. One step at a time. First step, rewrite the number. Okay, so what's this going to be? 180 plus 22, right? On your calculator, you got 202 minus 180 will give you what you need, right? Okay, so where am I? 180 plus. I'm in that quadrant, right? What happens to tan in that quadrant? Say it's positive, right? So it's just tan 22, and tan 22 is t. We good with that? Okay, nearly there, guys, nearly there. Okay, the next one after that tan 338 is tan negative 22. And the next one is tan 518 degrees. So if you get confused, just say, where is 338? 338 is over here. If it's over there, always go 360 minus that number, right? And 360 minus 38 is 22. So you can read, first step, just rewrite the number. 338 is equivalent to 360 minus 22. Just rewritten the number. Now I go apply reduction formula. 360 minus is in quadrant 4. What happens to tan? It's negative. There's no name change. Tan of negative an angle is equivalent to negative tan of that angle, right? The tan of negative 22 is equivalent to, which is just negative. Okay. What's our strategy if things are bigger than 518, bigger than 360? Just take your calculator and go 518 minus 360. What do we get? Okay, so this is equivalent to tan. So 518 minus 360. Are you with us, Irijwa?
Yes, sir.
Okay, so 518 always minus 360. And what do you say? 158.
Yeah.
Okay, now I start the sum from there.
Yeah.
Okay. Where's 158? 158 degrees is in that quadrant, right? So you're going to write it as 180 minus something. Okay, so the calculator go 180 minus 158, you get 22, am I right? So tan of 180 minus 22. I'm in this quadrant, 180 minus. What happens to tan there? Nearly there. Negative tan 22, which is negative. Sine 22. Okay, right. The next one is cos 158. Two more of these to do. Okay. Cos 158. Now be careful. Don't panic. First thing we want to do is we want to get to acute angle. Right? So 158 is where? Sorry. Okay. It's going to be cos 180 minus 22 again, right? You agree? Get it to acute angle, which is just 180 minus over here. What happens to cos? Okay, good. This is what I wanted. That's negative cos 22. Okay. Now, the most innocent ones are the most complicated in this kind of question. Okay. If what you're given, what was I given? I was told tan 22 is equal to t, right? Okay. If what you're given, if you have the same angle, same size angle, but a different trig function, then I'm going to use triangles. Okay, so the ones that look most, so you've got what I mean. I've got cos 22, but I was given tan 22. So if you've got the same size angle and different trig functions, you're going to use triangles. Okay. So, okay. What do I do? Well, here with triangles, guys, I'm going to use, remember this? Good old greeting. Remember Sokotoa? Which tells us sine is opposite of hypotenuse, cos is adjacent of hypotenuse, and tan is opposite of adjacent. Okay? Remember, you've got to be careful of the word Sokotoa because in Malaysia means hello, but in neighboring Philippines it means your mother is a. Okay, so you've got to be careful in which country you're going to say Sokotoa. Okay, so if I'm working in right angle triangles, right? So fill in your angle. There's 22. Just remind me, what would I call this side? Opposite adjacent to hypotenuse. So that'll be opposite 22. This one would be adjacent to 22. And this would be your. Okay. Now they've told us the diagram is drawn according to what you were given. Okay. So we were told tan 22 is equal to t, which means t over. What's the definition of tan in terms of Sokotoa? Opposite over. So if I go on my diagram, this distance of this thing over here is t. That distance is t. The adjacent distance is 1. Okay. In order to figure out cos, I need the hypotenuse, right? Okay. So in a right angle triangle, how do I find the missing side? I use Pythagoras, right? So let's call this h for hypotenuse. So the hypotenuse squared would be equal to 1 squared plus t squared. Now just be careful. If you were told can't just get rid of the squares. Because if I take 3 squared plus 4 squared, I can't just, I'm confusing myself now. H is just going to be the square root of 1 plus t squared. Okay, because I can't say that's equal to 1 plus t. Because like, yeah, I wanted to say this. The square root of 9 plus 16. I cannot just say that's equal to 3 plus 4. You with me? Okay. Can't square root them separately. Okay. So that just stays like that. So my hypotenuse is the square root of 1 plus t squared, right? So now I can go on to the question. What was I trying to work out? I was trying to work out negative cos 22. So it's going to be negative. What's the definition of cos? Adjacent over hypotenuse. So what's your adjacent? It's 1. Okay, and what's your hypotenuse? There's your answer. Okay, guys. Just don't write this down. But if I said to you, what is sine of 22? Go write down what actually you can. Put sine of 22b. What's sine? Opposite of hypotenuse. What's the opposite? So sine is opposite of hypotenuse, which is equal to t over root. When do I use the triangle? When the given angle, what you're given is the same size angle as. Okay, that's when you've got a problem and you've got to draw that little triangle. Well done, guys. Cool. We've got through a lot. Okay. That took us like 2 weeks in grade 11. Okay. Rudra, are you alive?
Yes, sir.
Okay. You can go have dinner now, Rudra. What's for dinner?
I'm doing my hair right now, actually.
Have you had supper yet?
No.
Okay.
Well,
Well,
we're
enjoy
having vlog though.
I hope your hair turns out well and enjoy your evening.
Thank you. You too, sir. Bye, guys.
Okay. Toodles. Oh, Rudra is a classic. Right. Okay. Stop sharing. And stop recording.